at the ground. Okay. High performance liquid flow enthalpy. So what is use of HPLC? Any idea? You have already given some presentation on HPLC, right? So what is use of HPLC? What is use of HPLC? Okay. For example, your course, what is your course? Nutrition. Nutrition, right? So for example, some plant is there, right? Take the plants now, sir. Plant name? Maize. Medicinal plant? Neem. Use of this medicinal plant, neem. Antibacterial. So we have neem plant and it has antibacterial action, right? So when we say neem, when we take what do you take for neem as antibacterial? Leaves. Okay. So when we feed leaves to animal, you expect it to have some antibacterial properties. If it has a secondary bacterial infection or something, you expect animal to get cured, right? Okay. So which is active component? What is active principle?
The content which is present in leaves that act as antibacterial.
Content. So one compound, when we say neem leaf, it has multiple components, right? It may have thousands and thousands of components. And when we say the neem has antibacterial property, so sometimes what happens if you are going to feed neem as such, that neem may give some adverse reaction also, some side effect we say, right? Side effect also. So you have antibacterial property, but we want to specifically harness that antibacterial property. Okay. So we have, for example, 10,000 compounds. What is compounds?
Aggregates of molecules.
Molecules, right? Individual molecules. For example, you have 10,000 molecules, and suppose one molecule has an antibacterial property. One antibacterial property. Okay, one molecule has an antibacterial property. We call it as a active principle. Okay, active principle of that molecule, because this molecule only compounds the antibacterial property to the neem. You suppose for now, right? It can be multiple molecules, like 4, 5, or 10 molecules, but we assume that it is only one molecule. So how do you identify that particular molecule? Now we have this vessel. We have this vessel. Neem. You have taken neem leaves. We have crushed it. We are mixing some solvent, for example, water or organic solvent. Okay. You have put it in the, for example, water. How many molecules are there now? 10,000 molecules. For example, if all our water sample, 10,000 molecules are there. So how to identify this molecule? So what is our objective here? We want to identify the molecule, particular molecule, right? Next, how much leaves after giving how much leaves do we expect to have antibacterial property? Random number you take for example, grams or something.
500 grams.
For example, we are saying 500 grams. molecules form that one, right? Active compound. So for getting the active compound with the antibacterial property, we have to quantify it, right? Like you are feeding the 500 gram leaves and you expect it to have some effect. But if you feed as a 500, animal may have some side effect. If it is having side effect, our motto is that we need one antibacterial molecule such that it won't give side effect. Okay. So after how much antibacterial molecule you have to feed to animal, then it will give effect, that you have to determine, right? So for that one, what you will need? Quantity will be need, right? So we have to identify, we have to quantify. Next, we have this 10,000 molecule. Now what do you want from 10,000 molecule? Particular one molecule, right? So what we call it as a, so out of 10,000 molecule, this, for example, this molecule is only of our use. So this is our molecule. Okay. So what do you do with that molecule? Extract. We have to extract, separate, right? Okay. So we have neem leaves. We have one antibacterial property as per you said, and now we want one molecule which will compound the antibacterial property without side effect. So there should not be any side effect. Okay, no side effect should be there. So how to get that molecule? How do we get that molecule? Okay, by chromatography. So how any idea, rough idea how from chromatography we can do that one? Principle of chromatography. Hplc is like Hplc equipment is there, right? So when we say Hplc, what words come to your mind? Hplc equipment related. One word used there. You are Snail, right? You have already given seminar on Hplc. Okay. So what words come to your mind?
High performance liquid. It is a type of liquid property in which high pressure. It is also called as high pressure liquid chromatography because
Pressure.
this pressure is used
Pressure.
to separate the molecule.
High pressure, right? Okay. Next, what word comes to your mind? Equipment related. Anything is there? Pressure. You write this in the book. Pressure is one thing, right? So what are the next things?
There might be graph generation according to the content.
Graph generation. According to content.
Liquid phase liquid.
Okay. Next word is first one high pressure, right? Liquid phases. Which are liquid phases?
Solvent. Any kind of solvent with liquid phase and organic phase.
Solvent. Next,
And stationary phase.
stationary phase. Next,
Silica. Used as a stationary phase.
silica. Next, stationary phase, and one more phase is there, right?
Mobile phase and stationary.
Mobile phase. Okay. Next, anything else related to this equipment?
Hello, sir.
Column.
Column.
Column stationary phase. Column is covered by stationary phase.
Column. It contains stationary phase, right?
Yes.
मला पण जायचं असेल pump. Next,
Detector.
detector. Next,
Software attached to.
software. ग्राफ जनरेट होते त्याला काय म्हणतो आपण?
Chromatograph.
क्रोमॅटोग्राम. Okay. So these are things we have already discussed in our class, right? You have already explained some of these things. So we have high performance liquid chromatography, and we have now we are going to discuss high pressure pumps, liquid phases, what is stationary phase, what is mobile phase, then column, detector, and the software chromatogram. Right? Anything else related to this one?
First, sample.
Sample is important, right? Because mean means that you have this mixture you have, we have to inject it somewhere, right? Next, anything else? So when we say column, so this is our column. Okay, this one is our column. Okay, this one is our column, and now it is packed with some beads. Some material is there inside here. This one, small material is there. We call it as a column packing. Okay, so this stationary phase, so you are told it is silica, right? Silica. So for example, this was our solution, 10,000 molecules. Okay. Some of you prepared this solution. So this A molecule is there, B molecule is there, C is there, D is there. Okay, different molecules there. Your particular one molecule you want to separate. Okay. So for example, how to separate this molecule?
So when we run these apparatus, then the pump gives the pressure, then by their molecular polarity of the substances, they are separated.
Polarity. Next. So for example, there are first year uses student and EMS is secondary student.
They are getting attached to the silica, and which are non-polar, they will separate.
Polarity, polar and non-polar. Okay. So for first year student and last year students, some knowledge differences there. They know master student know some more things. Based on that, you are applying some criteria, right? So when we say you say polarity, these are one criteria, right? One criteria of molecule. So for example, this molecule has some polarity. So when we say polar, so what do you understand by polarity? What is hydrophilic and what is hydrophobic?
Water
is
and water.
fear,
What is phobia?
Fear.
fear,
Fear. So when we say hydrophilic,
Water loving.
water living, right? Water loving and hydrophobic. Water hating. Okay, these are two things. Water loving molecules are there, water hating molecules are there. Okay, so this is one criteria. Is there any criteria you can think of? Another criteria means if this A molecule is there, when it will love the water, if it tend to bond hydrogen bond with water H2O molecule, right? So it is water level, So they form hydrogen bonds. That is why we call it as a water level. Or there are some one part of molecule, chemical part of chemical structure, which tends to give the water level. Where what is water hydrophobic? When it will be hydrophobic?
When there is no OH bond.
When there is no OH bond. Okay, so this one are our chemical organic chemistry part, right? This is basic organic chemistry.
Yes.
So if you have OH group, it will be water level. It will be forming the hydrogen bond with that molecule, so it is a water level. And if there is a alkane, like chain of fatty acid, for example, fatty acid is a long chain of fatty acid, right? So when we say fatty acid, so we have already studied in first year, right? This
Single bond.
like this chain. So when this membrane is there, this polar head, they tend to interact with water, and hydrophobic chain, they tend to be inside. Okay, so hydrophobic molecule tend like to interact with each other, and this polar molecules they like to interact with water outside. Okay, outside membrane there is water. They like to interact with the water. That is hydrophobicity. Hydrophobicity means some molecule they like to interact with the water, and hydrophobicity means some other molecules they like to interact with the
Lipid layer.
other means they hate the water molecules like fatty acid chain. So they interact with them, and then they
Attach.
Cross the membrane.
hydrophobic molecule. If this is hydrophobic, this is hydrophobic, they will come together.
Yes.
If this is water, they will come together. Okay, so this is the attraction based on that one. Okay, so this was one criteria. Any other criteria can you think of?
Pressure difference.
Pressure difference. Pressure difference. No pressure we create. We create the pressure in this pump. When we are passing the molecule, so basically stationary phase we are taking here, right? We are packing it with the stationary phase. Then we are passing mobile phase to that column. Okay, we are passing mobile phase to that column. So this stationary phase, if it is like a polar molecule, stationary phase, for example, is polar. So silica, for example, silica is a polar. Okay, silica is a polar. Means what we will do? We will pass the mobile phase to this one. It will have some water component plus organic acid, organic component, okay, organic component. So when we pass our solution, so this molecule ABCD molecule are there. When you are passing ABCD, for example, to this one, so A is interacting here with this silica, okay. B is coming, B is interacting here, C is interacting here with one silica molecule. D molecule is there, D is interacting here. Okay. Now we are passing to our mobile phase. So what we'll do? Okay. So we are passing ABCD from there. Okay. This solution is there. ABCD we are passing this solution. Now all has come here. Okay. So next step is a elution step. Okay, ABCD we are passing. The silica is tightly packed. Okay, when very small molecule are tightly packed, and if you want to pass mobile phase to them, what will happen?
Break.
It will create pressure, right? So for example, our one hollow tube is there. You are passing the water through it. What will happen? It will easily go through.
Go
right?
through, yes.
Now some material you are packing with some material, for example sand molecules or some glass beads. Okay,
Push.
silica molecules you are passing with small molecules very tightly. What will happen if you pass solvent? Will it come directly?
No.
It will not come directly. It will get stuck. So what we have to do? We have to apply the pressure, right? We have to apply the pressure so that this mobile phase will move through that molecules, right? So that is the meaning of high performance, means high pressure is applied in this one, right? Because we don't want to sit all the day observing whether now it will come down, now it will come down. So we want to give the pressure to the pressure here. So we want to give pressure to this mobile phase so that it will move easily through this one. Okay. So our point was that we have a molecule which is a hydrophilic. This a molecule is a hydrophilic. For example, it is very much hydrophilic. Okay. So B molecule is there. It is also hydrophilic. It will be less hydrophilic. C molecule is there. It is hydrophobic. It doesn't interact with like to interact with water.
Negative,
Okay?
negative,
It
negative.
doesn't like to interact with water. D molecule is there. It is hydrophilic. Okay, hydrophilicity. So these types of hydrophilicity are there. So now you tell me which molecule do we expect to get first?
C.
We are passing mobile phase. Now we are talking about the whenever silica, this stationary phase is a silica, means if it is a polar, we call it as a normal phase
Yes.
chromatography. Chromatography is a separation technique, right? Normal phase. When this silica molecule is a polar, we call it as a normal phase chromatography. Okay. So now we say this is a polar silica. Now we are passing this ABCD. So this is a mobile phase. Okay, mobile phase we have done. Now here we are injecting sample. Sample injection is there, for example. This sample contains 10,000 molecules. A, B, C, D. Right now we have taken specific about ABCD. Okay. So which molecule do we now we pass this to pressure? Then we have to see the dilution. We can send it to the detector. What is detector?
Detect the molecule.
Detector means it will detect the molecules, right? So different types of detector is there. Simple we will try to discuss. Simple UV visible detector we will try to discuss. Okay, UV visible detector. So when we are passing for example, we are passing this solution from this tube. Now this molecule will come here. Okay. Based on spectrophotometric principle, we are passing the beam of light from one position to another from that molecule. Okay. So we are passing the beam of light such that it will hit this molecule and some light will come here. Okay. So this is our incident light I0. This is our transmitted light. Okay, so we have the equation here. Upside if you see, we have light source. Okay, we have light source. This is our light source. So bulb is there. Here, it is flashing the light. Now this is the beam of light with I0 intensity. We are passing it through the solvent. Okay, so monochromator is there. Monochromator means so this visible light. If you are passing the visible light through monochromator, so it will give the 7 color. like rainbow. In the rainy season, clouds are there. A beam of light is passing through that cloud, it will split
Spray.
apart, right? So basically, this white light what we see is composed of 7 light, visible light. Okay. So the purpose of monochromatry is to separate the light into individual wavelength. Because now this wavelength of light we have selected, it is for example red in color, which you are different color, violet, indigo, blue, green, like that, right? Based on its wavelength. So you can see this light is splitting. So there, so yellow light is passing through this one. So suppose this is yellow light, it is passing through this molecule. Now incident light, and this is a transmitted light. Okay, so this is a transmitted light. Now what will happen? So this is a sample cuvette. So this is a principle of spectrophotometer, right? Already we have seen spectrophotometer principle. So I0 light is there. So how do we calculate the what we can calculate? If you are taking for example log of I0 incident light divided by the transmitted light. Here we say incident light. Here we say transmitted light. Transmitted. So incident light divided by transmitted light and logarithm if you take, and if you do epsilon lambda c. So what is this one? Epsilon is a extinction coefficient. Okay, this is the extinction coefficient of that molecule. So particular molecule A, B, C, D molecule, it will have its own extinction coefficient. Okay, so this is extinction coefficient. Lambda is path length. So how much is this length? Okay, how much length this molecule is passing, light is passing. So cuvette length. Okay, and C is a concentration. So if you are measuring this concentration at the particular snapshot of the time, how much molecules are there? If it is detecting A molecule, for example. So this means we, for example, this is A. A is directly proportional to lambda C. This lambda, this path length we are not going to change. So we say absorption is directly proportional to the path length. Extinction coefficient is also constant for a particular molecule. So we remove it. We say absorption is directly proportional to constant. So what will happen if we are, for example, we have 10 A molecule. Then how much will be the absorption?
Okay.
A random number you can tell. 0 to 1. 0.7. For example, you are passing the 10 molecules of A and it has a 0.7 absorption. Okay, 10 molecules is there in this chamber. In this chamber there are 10 molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 molecules is there, and you are saying the absorption is a 0.8. Basically, equipment is ready just for accuracy. Okay, now what will happen if absorption is if instead of 10 molecules there are 15 molecules, 15 molecule of A, then what will be the absorption?
15 into 0.7 divided by 10.
No, you just tell one number whether it will increase or decrease. Increase number or decrease number you tell.
Increase.
Increase 0.7. Next number
0.75.
0.75. What will happen if it is of 5 molecules or 4 molecules? What will happen? Absorption of A. What will be the absorption of A?
0.28.
0.28. So basically, when we say A is directly proportional to C concentration, if lesser molecule is there, we expect lower optical density, right? Means lower absorption, because lower number of molecules are there. It means that the absorption will be lower, and if higher molecules are there, then absorption will increase. It is like it is becoming 0.7. So 4 molecule is there, 0.28. If 10 molecule is there, 0.7. 15 is there, 0.75. It is increasing. So we are passing it through the column, and column is a hydrophilic column, right? Column is hydrophilic. So you tell me now, we are collecting the fraction. It is passing through the column. For example, it is passing for 10 minutes. You are applying the pressure. Once pressure is applied, it will go from here. Mobile phase will come here. We will inject the sample here. It will come to this liquid chromatographic system, and for 10 minutes it will be traveling from 10 minutes here to here. Okay. Or we have collected this fraction. Okay. Detector will detect the concentration. Okay. So this quantify function is done. Quantify function is done. Okay. Now we have to separate the molecules. For our liquid chromatography, we have to separate the molecules. So what we are going to do, you understand this one, right? UV visible incident line. Now we have to separate it. So one tube we are taking one tube. We are collecting it here after 2 minutes. Once you start this Hplc system, after 2 minutes, we are collecting the first fraction collection. Okay, so you are passing it through this one, and now we have collected one tube. 2 minutes. This tube we have collected, we have kept it at the other position. 2 minutes. What you will do? You will wait for 2 minutes again. You will again put another tube here. Now it is how many minutes? 4 minutes. After 4 minutes, we are collecting some 1 ml sample. For example, you are collecting 1 ml. Okay. So basically, the flow rate is that how much sample passes per minute that solution. But 1 ml sample we have collected. For example, after 2 minutes. After 4 minutes, we are collecting again sample we have collected after 4 minutes. Okay. Now what? After again 4 minutes, we will put another tube. 6 minute fraction we have collected. After 6 minutes, after 2 more minutes, after 8 minutes, we are taking sample. Okay, so we have collected sample from here. Okay, sample collection. Reading. Here sample reading is done, right? Detection. Sample reading. So identifying the which sample is there, it has been done unique exception based principle detector. Okay, one simple detector we have seen. Now this is a separation. Separation here it has been done. So my question is, we have collected 2 minute sample, 4 minute sample, 6 minute sample, 8 minute sample. Okay, 4 samples we have collected, and we have 1000 molecules. Out of this 1000 molecules, we are just concentrating on first ABCD molecule, right? So after 2 minutes, which sample will get in 2 minute sample? C. Which sample will get in 4 minutes? Which sample will get in 6 minutes? A. Okay. Why will get C sample in the 2 minute position?
Because silica is polar and the C is a hydrophobic molecule, so to silica the hydrophilic molecules get attached.
Okay.
So it will elute first.
So we have column. The column is filled with silica. Silica is hydrophobic, hydrophilic. This is what molecule Snail told? C molecule. This is the molecule. It will be passing. A is passing, B is passing, C is passing, D is passing, right? So we have ABCD molecule. All 4 are passing. Okay. ABCD. All 4 are passing through this column. Now we are concentrating on C right now because she told after 2 minutes C will get. So this is a hydrophilic column. Silica is a hydrophilic column. C, why C will pass first? Because it is hydrophobic. So what will happen if hydrophilic, this is hydrophilic and this is hydrophobic, it will try to get away from it easily. It don't like this column, silica column it doesn't like, it want to get away from it, so it will try to repel from it. Hydrophobia, right? Hydrophobia is there, right? Like in rabies, there dog doesn't love water, so it try to avoid it. So likewise, this C molecule try to avoid the water, it will easily pass through water. That is why we get C first. So C is, if you observe at this position, C is coming first. Okay. Why D will comes second? After 4 minutes, why will you get D?
Because hydrophilic nature is less than other compounds.
Okay, so we have plus 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 plus. So this you can see it is very hydrophilic. It is comparatively lesser hydrophobic, and this is the least hydrophobic among A, B, C, C. So we expect. So C is done. Now ABC is there. ABC is there. The A is very much hydrophilic. It is attaching here with this silica. Okay, it is very tightly attaching with this one. B is hydrophilic. It is again attaching with this gel membrane. Now D molecule is there. It is also attaching with this molecule. Okay, but what will happen during the elution step? This molecule has a lower force of adsorption, right? Adsorption. We say, for example, adsorption. It is getting adsorbed with this one. Okay, so this is getting easily eluted first. That is why we will get D molecule here. After C, we will get D molecule. Okay, after C, we will get D molecule. And by the same way, B is attaching with the lesser strength. That's why we will get B here. And again, with the A is very much hydrophilic. So A is there. Okay, A will be there. Okay. So now we understand why we will get 2 minutes, 4 minutes, 6 minutes, 8 minutes. C, D, B, A. Okay, like this molecule we can identify. So we have identified the molecule, we have quantified. On the UV detector we can quantify. Extraction we have done. Extraction means we are dissolving in particular solvent, whether water solvent or the organic solvent. And then we are separating with the chromatography technique. Okay, so like this. So when we are passing through this one, how we will know? How will the elution step we have discussed, right? A, B, C, D. How to elute this one? How this elution works? How this elution works? So we have, for example, 90% water first, 10% organic solvent, okay, 90%, then 10% organic solvent. Okay, so it means that water is more means it is more hydrophilic. Mobile is more hydrophilic at this position. Initially we are passing through this one. Before passing, what we'll do? Before passing sample, we'll be doing equilibration, right? Before sample is passed, equilibration means only mobile phase you are passing through this one. So the column will get wet and all solution means it will get equilibrized. Okay, equilibration step. Then water is 90%, organic solvent is a 10%. Okay, so 90% water means which solvent will elute first, very hydrophilic solution. So hydrophobic, C is eluting first. So as the time passes, we are creating gradient. We are creating a gradient here. Okay, gradient means we are slowly changing this concentration. This water, now we are taking say 90 ml of water and 10 ml of organic filter. After some time, we can create like 80 ml of water, 20 ml of organic solvent. At the end, you can create 80 ml of organic solvent, 10 ml or 20 ml of water. Like that, slowly. Based on the property property of this elution, it will change and it will be getting eluted. Okay. So detector is there and this one is there. So for example, this is detector. It is generating some graph. Okay. We were talking about some graph here. So here we were telling that ABCD is getting attached here. What we call it as a retention. We call it as a retention, right? The molecule is getting retained on the column, so we call it as a retention time. Retention time. Okay. And here on the axis we can say absorbance. Okay. Absorbance. And based on absorbance value, we can also interpret it as a concentration. Okay. So what happened? So we are observing at 1 minute, 2 minute, 3 minute, 4, 5, 6, 7, 8, 9, 10. Retention time. After 2 minutes, 4 minutes, 8 minutes, we are observing. So here it is 1 minute, right? For example. So when we say equilibration, when you are passing the mobile phase only without sample, if you are passing through this one, you will get one peak here. Okay, one peak you will get here. Okay, so this is the first peak which doesn't have any sample. Okay, so after this peak, we will get to know the baseline. Okay, so baseline is there, so this peak is there. After this one, C is coming. As C is coming, some absorption reading will be there. Okay, so C has a this absorption. Okay, so baseline is fixed. C has this absorption. After 4 minutes, we are getting D. After D, it has, for example, very high concentration. This concentration is very high, so peak height is very high. Okay. Next, 6 sample has a little bit lower concentration, so this peak is coming as a smaller. And after 8 minutes, again this peak has a very high concentration. Okay. So what happens is that we are calculating the area under curve. Okay, so this curve is there. This 2 minute area we are calculating. 4 minute area we are calculating. 6 minute area. This minute area. Based on this area calculation, this is we call it as a chromatogram. So graph we were discussing, right? So based on this chromatogram reading, we know the actual concentration, which is the actual concentration, and where this peak is coming, which is height and which this one. Based on that one, we know the compound. Okay. So different compound has a different wavelength. So if you are applying the different wavelength in this detector, then you can detect the multiple samples. Okay. If you are changing wavelength, for example, glucose estimation, cholesterol estimation, total protein estimation is there in our microscope. At particular quantitative estimation, we use the particular wavelength of light in the spectrophotometer. Likewise, if you use different wavelength, we will get to know the different compounds here. Okay, so this is basically a high performance liquid chromatography, which is used to separate the compound. So now we have got the A, B, C, D. Okay, so this compound we have got here from this chromatography. Now, what is your job? If you are doing some research related to because you are a master student. So what you can do with this one? What was our first plan?
Extraction of active principle.
Extraction. We want to extract the active principle from
Neem.
neem So initially you were feeding the neem, 500 gram of neem to the particular animal, and it was giving antibacterial property. But the problem was that the animal was also showing the some side effect. We don't want side effect. We want only the clinically beneficial effect, right? Only antibacterial property we want. So it was getting unnecessary inflammation at the legs position or this some rashes on the skin. We don't want that one. We only want the bacterial count to be get lower in the animal. So what can you do with this one? A, B, C, D, we have got. We have got A compound, B compound, C compound, D compound. Likewise, 10,000 compound. For initially you could
Identify the compound.
you have identified the compound with the chromatography, right? Or if you want to identify it further, very specifically, you can use the mass spectrometry also. Okay, so basically we are talking about simple chromatography right now. So ABC compound is there. So what can you do with this compound? What is our aim?
Extraction.
Actually, so what it does?
Beneficial principle.
Antibacterial action. Antibacterial action, right? So what you can do is that you can take this A fraction, you can give to animal, and you can see whether it has antibacterial action. You can give B solution to different setups. So here for 6 animal you have given A fraction, or 6 animal you have given B fraction, 6 animal you have given C fraction, 6 animal you have given D fraction. So and just for number statistically actually you have to calculate how much animals, but 6 animal for example you are taking. So group of 6 animal you are doing, you are giving the A fraction to all 6 animal, B fraction to 6 animal, and all these have the and some infection in this one, right? Like this one, and one group of animal just normal saline we are giving. Okay, X group of animal. So this is a control animal. So we have infection induced in that all A, B, C, D, X animal. These have infections, but we are giving A, B, C, D compound to respect to 6 animals, and for X animal we are not giving anything, for example, or we are just giving normal saline to this one. If you are testing the positive control, so non-antibiotics, for example, ampicillin you are giving to that animal to see the effect, and then you are comparing the effect of this one. So basically, this is the function of the Hplc, liquid chromatography, high performance liquid chromatography, right? You have understand this point, right? Is there any question regarding this question? Okay, because your course is nutrition course, right? Nutrition is you will be coming across active principle. So different active principle, this one. So talking about the Hplc, what are different kinds of Hplc? Different types of Hplc. Which are different types of Hplc? Chromatography, different type of chromatography. TLC,
Gas.
Gas chromatography.
Chromatography.
gas chromatography,
Paper chromatography.
paper chromatography, next, based on principle, how Hplc is classified?
Liquid and
Liquid,
gases.
liquid chromatography, Hplc and gas chromatography. Okay. Now we have seen the normal phase chromatography, right? What we will call the chromatography, instead of silica, you are attaching silica with the carbon 80. So the silica instead of hydrophilic it is become hydrophobic. So composition, accordingly composition of normal phase also you can reverse
Reverse phase chromatography.
reverse phase chromatography, right? There are different type normal phase. So this is basically adsorption chromatography which we are seeing, right? Adsorption chromatography. In this one we have normal phase chromatography and we have reverse phase chromatography, right? Reverse phase chromatography. Next, this is one criteria, right? Hydrophilicity, hydrophobicity. Can there be affinity criteria? So some protein molecule you want to isolate, like ELISA. How ELISA is there? ELISA works. Antibody is there. Some protein component is there. Antigen is there. It is getting attached with that antibody. Okay. What we call it as a
Antigen-antibody reaction.
affinity.
Yes.
Okay. It has some affinity with this epitope molecule, antigenic epitope molecule, and it is getting attached with that one, right? So we can utilize that principle. We can call as a affinity chromatography. Okay, affinity chromatography. Next, ion exchange. Some ion exchange chromatography you can do, right? So some ions are getting exchanged, and this we are detecting. So that is ion exchange chromatography. Anything else? So for just for wait for 2 minutes.
Hey. So we are talking about affinity chromatography, right? Affinity chromatography. So for example, this one is a simple column. Okay. So this nucleic acid is there. It is getting attached with this membrane, and then we do all steps. Like first bacteria we are taking, we are lysing that bacteria first. We are doing the homogeneous solution, resuscitation, lysis, neutralization we are doing. Then we are centrifuging it. So after centrifugation, what will happen? This bacteria after lysis it will get all lysed, right? What is our motto? We want to use to the DNA or plasmid. For example, plasmid from that bacteria. So this supernatant we are taking, we are putting the supernatant on this column. So here it is, the opening is there. So we put the supernatant on this column. It will go through it. So we centrifuge it. After centrifugation, it will come in this position, right? In bottom tube it will come. We are discarding it. After discarding it, we are washing it with the some elution solution. Some buffer solution we are passing through it one, right? Buffer and alcohols we are passing through this one. Now buffer and alcohol we are passing. So last step is the elution step. Elution step, we are exchanging this tube and we are putting new tube. We are putting here. What is elution? Elution means now DNA has got attached on this column. We want to get this DNA plasmid in this tube. So we are passing the elution solution through this tube. Now it is coming in this tube. So we call it as a plasmid. Okay. So this is how this chromatography principle works. Okay. So for example, you consider it as a affinity chromatography based. Or if it is a protein based purification, in protein column also there are the antibodies we are attached with this column, antibody attached things, and then we can separate very specific molecule. Out of 10,000, for example, you want only A molecule. How to detect 10,000 you can detect with UV, for example, but you want to separate only A. So you will not prepare 10,000 tubes, right? 10,000 tubes and 10,000 reading you won't take. You only want single. So in this column, what you will do, what you can do, now the aim is to detect only A molecule. So here we will attach with antibody. It has an affinity only for A. So now this A will go and bind with this antibody. Other molecule won't bind. In that way, all molecule will elute first, and afterward that you will put elution buffer in such a way that this affinity between these things will get broken, right? So pH, based on pH change, you can do that one. And now the last molecule you get, only one molecule you collect, it will be the A molecule. So this is like affinity based purification of the molecule. Okay, so you understand this affinity chromatography and chromatography system, right? And gas chromatography, it uses the gas. So in addition, the detector based different detector are there, PDA detector, UV detector, and mass spectrometry is another one technique which again can break the molecule into ions, right? Into ions it can break and then it can detect. Mass spectrometry you have explained, right? It can detect the mass, it can break down molecule into individual masses and then it can detect the mass to charge ratio. Based on mass to charge ratio again, there will be graph generation and that graph generation will show which molecule is there, right? So that was about the HPLC liquid chromatography, high performance liquid chromatography. Okay, you can start.